Hello everyone. In this problem, we will go to a mathematical problem of energy theory for accident scenario inspection. So this method and the problem solving will be based on energy theory. So given we have some given data. Firstly, given is the uh, skidding vehicle is A, which weight is 200 kg, that is WA. WA is 200 kg and it will and it will skid up to 36 meter before applying brake, and the stationary vehicle is the B, which has weight of 1500 kg, and both the vehicle will run together, call it together, skid together up to 14 meter, and coefficient of friction is F, which is given 0.5. So you have to calculate initial vehicle of the speed. To calculate initial vehicle of the speed will be V1. It will be initial vehicle speed. We have to calculate the V1. So let's depict the scenario. So if we want to depict the scenario, our A vehicle will travel, B is a stationary vehicle. When A vehicle is travel, its speed is V1, and when brake is applied, brake is applied to V2. The vehicle is applied to V2 brake, and it will collide with A and B will collide together and traveling at V3 speed, and it will travel up to S2 distance and stopped together after S2 distance. The A and B vehicle will stop, and after applying brake, A vehicle will travel up to S2 distance, S1 distance. So we have V1, that is vehicle A will travel at V1 speed initially, and its weight is WA and weight of B is WB, which is stationary vehicle. A vehicle will travel before applying brake up to 36 meter, that is S1. A and B collide together and move at a speed of V3, and they will travel at S2 distance, that is 14 meter, and it will stop at V4, which is 0 speed. So we have to calculate the V1 speed. So in this math we have to calculate actually backward. We have to calculate in the backward in that way. So first consider the after collision situation. So after collision, loss in kinetic energy will be work done against resistance, against friction skid resistance. So loss of kinetic energy here is our weight WA plus WB, and the formula is half of mg v square. The V will be, here the speed difference is V3 square minus V4 square. So the formula is WA plus WB into V3 square minus V4 square divided by 2G, and work done will be, both vehicle are now joined together after collision, and its friction is F. Friction value is F is given 0.5, and it will travel up to S2, that is distance travel is S2. So here our WA plus WB will be checked out. Our V4 is 0, so the equation becomes V3 square by 2G equals to Fs. Our F is 0.5 and S2 is 14 meter, because after collision it will travel up to 14 meter and come to complete stop. So calculating from here, V3 will give us the value of 0.5 into 14 into 2 into 9.81. G is 9.81, give us the value 11.71 meter per second. This is the speed of V3. We do not need actually the V3, we want to calculate the V1. So after collision is this situation. Then we have to go to the at collision, during collision situation. At collision, momentum will be same. Momentum before impact will be equal to momentum before impact will be equal to momentum after impact. These two value will be same. So momentum before impact is only a vehicle, that is WA. It will WA by G, that is the mass, into is velocity is V2. Here is the V2 velocity, and after impact it is become two vehicle joined together, and its mass will be WA plus WB by G into the speed becomes V3. So in that case V2 will be WA plus WB divided by WA, our G will be cancelled out, into V3. We know the WA is given here in the question, that is 2000 kg or 2 ton. WB is 1.5, WA is 2 ton, multiplied with V3. Our V3 is calculated already 11.71, so V2 will be 20.5 meter per second. So that's it to calculate the V2. Next we have to calculate before collision situation. So for before collision, again our loss in kinetic energy will be work done. Work done, we can write one thing, work done against friction. Work done against friction. It will be work done against friction. Against friction before stop, and it will be work done against friction against friction during brake applied. In that case, our weight is WA into the speed is V1 square. It will change from V1 square to V2 square divided by 2G, because we are converting weight to mass. Is mv square. Half mv square is the kinetic energy, and work done equal to weight into friction value into S1. Here our displacement, that is S1. Now we can cancel out the WA. We have V1 square minus V2 square by 2G. F is 0.5 as per the question, and S is 36 meter is given. So we know the V1 square, V2 square. V2 square is 20.5 square. G is 9.81. 0.5 into 36. We can calculate V1 directly from here, and solving V1 value, the value will be 27.8 meter per second. So since it is in meter per second, we can convert it to kilometer per hour by dividing by 1000 and multiplying with 36. We get 100 kilometer per hour. So the moving vehicle has the speed of 100 kilometer per hour at the beginning of the collision, or the pre-collision speed of the vehicle is 100 kilometer per hour. So that's it all about this math. So we divide the math in the three stages. One is after collision, at collision, and before collision. Both after collision and before collision, we use the formula loss in kinetic energy equal to work done against friction, and at collision we use momentum, that is momentum before impact, and momentum after impact will be same. And this is the energy theory through which we can calculate initial speed of a vehicle, initial speed, that is pre-collision speed of a vehicle. And this all about this math. Thank you so much for watching this video.